Hello everyone, welcome back to another tutorial presented by CodeCyclone. Today we are going to go into my AI controller that I showed you last time a little more in depth. I got a few messages from people who were a little confused on some of the methods I had, so I figured I'd go through and thoroughly explain how my controller works and what I've been doing with it. And while we're going through, I'm going to point out some bugs that I found in it that I'm planning to fix. That way you guys are aware of them as well if you use this code. Okay, so first off, I'm extending from the standard AI controller, so none of the Unreal Tournament stuff is in there. It's clean, it's very, very bare bones. Alright, I have three variables that I have defined. A TGC pawn, which is just the equivalent of a UDK pawn, and I called it target. And this is going to be the guy that I'm going to be focusing on as far as attacks or following or chasing or any of those states go. A TGC walkway, which is just an object, a placeable object, a path node even. You could relate it to a path node if you're familiar with that is, but it's just a object on the map that I can reference, and I'm calling it current walkway, and this is going to be the current walking point that I'm going to. The TGC pawn last greeted is used. That way I know what was the last thing that I talked to, because my pawns in this game have voices, so the last time I emoted or taunted a target. Okay, now I mentioned this before, if you're not very math heavy, I'm going to go over this just so you guys get an understanding. This is the distance formula. It's derived from the Pythagorean theorem. Which all this does is it gives you the point, or the distance between 2 points. In our case, 2 vectors, which represent x, y, and z in a three-dimensional space. So what you do is you take the x values of both of them and square them. Alright, and these statements here, just make sure that they're not negative. They should never be because you're squaring them, but I don't know how, but somehow in Unreal Script I was getting a negative value, so I put these in here to catch that. Again, no idea how, but just whatever, it went with it. Alright, so you square the x's, you square the y's, and you square the z's. You add all three of those up and square root them, and that's your distance in 3D space between two three-dimensional points. Alright, and that's you're returning d, the distance. Alright, this emote target you can ignore, it's just telling my guy to play, his voice, whether it's an emote or a threat. Alright, pawns near. It returns a boolean, and all it's doing is it's checking for each actor. That's a TGC pawn, so another possible player or actor, or not actor rather, but just simply another pawn. We're going to do a distance formula on its location versus my location, and if it's less than the view distance that I've set for myself in Unreal units, usually it's 512 to 1024, somewhere in there, depending on the player, and this controller is physically able to see the other pawn, so if it can draw a straight line to it and see it, and the person I'm looking at's player type is equal to the player type that I am targeting, and of course other is not equal to myself, and this is just for chance, and rand range 1 to 10 is less than will recognize target. This is a integer, and this just gives me a small chance of still ignoring a target if I see them. Just, you could count it up to not recognizing them at first, or just whatever. But if all those conditions are true, we tell ourselves that the target is other, and we return true. So we did find one near. If it's false, that means nothing was near. Okay, so make sure we're good on time. There we are. Okay. Alright. Now I introduced states in the first AI video, and I guess perhaps I didn't do too well in telling you what those were. So let's open up Paint here. It's loading, okay. Come on. There we go. Okay. So, what we are describing with states is what they call a finite state machine. And all that is take the idea that, say we had, say like you take yourself, for example, you're walking to the kitchen, to your kitchen, you're looking for food. While you're walking there, you're in a state called walking, which we'll denote by this W. Okay? When you're walking, you're going to check to see if you're in the kitchen. So, if you are, you're going to go to a state idle, denoted by I. And we'll add text to this in a second. We'll just... in kitchen. So we're in the kitchen, we go to state idle. From idle, we're going to determine what our next idea is. If it turns out that we are not in the kitchen, say we're walking and we go to idle to determine our next action, it says, hey, we're not actually in the kitchen. We're going to go back to walking towards the kitchen. And this process is going to repeat until we're in the kitchen, and this will no longer be called. Okay? When we get to the kitchen, we're going to jump states into search, which we'll just define as SE, search. So we are searching for items. Alright, and it's going to go back and forth until it finds an item that we want. When that happens, we're going to go back to the walking state to go to that item. And when we get to that item, it's going to return, and we could have a third state even, you know, retrieve item purchase, you know, for example. So basically what a finite state machine is it's a collection of events and states that describe how a system works. In this case, take the pawn that I'm describing, or the AI controller rather that I'm describing. He starts out in a state idle. Alright? And at the very beginning, if pawns are near him, so I hate paint. So if pawns are near him, we're going to go walking. If, and that, well, actually that returns. So if this returns, it's going to check the distance and say, hey, either we're not far enough and we're going to go to walking, or we're not close enough, we're going to go to walking. If we are close enough, in this case, we'll say it's an enemy, we're going to go to attack. Okay? It's going to check in here. Are we close enough? Is this an enemy? If it is, attack. And then, of course, we're going to return. And you get the idea. It's going to walk to the target. If we're near the target, it's going to check if we can attack him. If we can attack him, it'll return and repeat until he's dead, or until he gets too far away, and it'll go back to walking. But that's all a finite state machine is. You're somewhere. If this condition is true, you go to this state. If this condition is true, you go to that state. And it repeats until the actions are done. And this type of diagram, this is actually a very crude and very, very small representation of how complex these things can get. I mean, these things can branch out. You want to try to keep them small, but it's not always quite that nice. But you really, you know, from this can't tell how complex they can get, but they can get exceptionally complex. But they are very good for designing logic and are highly used when you're doing AI, and highly useful, because you can actually, you know, write out here whatever with these, where those squiggles are, you know, what's happening there. And it allows you to help debug code too, because I've had issues where I'm like, why is this doing this? And I'll trace out the finite state machine, or the FSM, and, you know, I come across something, oh, I should have done this instead, it's getting caught here. And that's the idea. Alright, so going back to our code, if we're looking at it, we have what we call the states. So auto, this keyword, is defining the first state that we will start in. It automatically will start in state waiting, which is kind of like my idle state. Alright, we got a few functions here, which you can define in states. You can actually override functions inside of a class. It's almost like polymorphism, since Unreal Script doesn't really explicitly use polymorphism, but this is one way of overriding. We can have many states with many different definitions of the same function, so it's kind of the same. But this is just like pawns near. It's the same idea except for walkways. Now, once you get past all your function definitions, which should be defined at the top just for ease of reading, and I think it's syntax, you have to have it up there. But what you're going to do is you're going to have this label begin with a colon. This is going to denote the actual code that'll be run when we hit this state. First, we're going to tell it to sleep for 2 milliseconds. That allows, the pawn to stop moving, things to finish up, so we don't clip, like animations on each other or something like that. Then, the first thing we're going to check is if pawns are near. If there's pawns near, we're going to go to state run 2, which is the chase. If there's a walkway near, we're going to go to walking, which is just run 2 for walkways. Alright. If nothing happens, we don't have a pawn near us or a walkway, we're just standing there. Just go to state waiting. It'll just keep repeating until one of these two events is true. Let's say, for instance, pawns near came into play and it returned true. We actually had a target. We would go to state run 2, which is right here. We say state run 2, begin. We sleep for another 2 milliseconds. If we cannot see the target, so if not can see, which just translates to can see target is equal to false. If we can't see him, it goes to waiting again. We lost him. What happened? If the distance formula returns a location that is greater than 20, we want to run at our target. So I have the pawn running at them. We set the rotation of this controller to the rotator of the target's location, which is going to give you a rotation pointing at that target. Then we say global, which is, it's like I said, you can overwrite functions inside states. Well, global calls the version of this function on the outside of the state. So if you're familiar with the term scope, like this is the scope of the state, global returns the scope that defines the class, not that defines the state. It's one step up. Okay? We're going to move toward that target with a 15 unit offset. And we're going to tell it to run again. So it'll go to run 2 and come back up here and repeat until, as long as one of these are completed, which it has to. So, it's going to keep running. Eventually it's going to get to being less than 10. It's going to approach the target. When we approach the target, we're eventually going to get here. We're going to mote the target, which is just, it'll either say, hey, or, you're going down, or whatever threat or greeting that you want to give. This little bit right here is checking to see if we can attack. If we can, it'll go to the state attacking. If not, it just goes to waiting. We're just standing near that person. We're following them, or whatever. Let's say we go to attacking. It's got a few functions here, and it'll go through if you're close enough, within 10, go to state run 2, or if it's greater than, rather, it'll try running at them. If you're close enough, it'll try to attack target, which again, if you can attack, and the last time you attacked is not more than the attack time, so like if you can attack every 2 seconds, it'll only let you do that. And you can still see the target, so they're not like on the other side of a wall or something. You'll set your last attack time, you'll tell the voice to play the attack sound, your target will take some damage, which I've defined as a random between a minimum and a maximum. Oh, excuse me. And all the other functions there. And then we also broadcast, just so I can see debug-wise, that such and such attacked someone else. Alright. Hopefully this has cleared up a little bit of the confusion with you guys. Again, I'm glad that you guys are sending me messages. If you have any more, send them my way. Hopefully this has cleared it up. If it hasn't, the UDN actually has a really good tutorial on AI, and a lot of other people like Mulgini, did a really good one, and actually that's where I learned originally from. So go check them out. Very good on theirs. And till next time, guys. So again, if you have any messages, send them to me. If not, hopefully this will help you guys get through that. So till next time.